Hello everyone. In this video, I'm going to do an example involving electrical power. This example comes from a textbook that I use when teaching an introductory physics course. The question says that a 45-watt lamp and a 100-watt lamp are connected in parallel to a battery of 115 volts. Just note I had to rewrite the epsilon symbol in the question due to a mistake with the font, so I just wanted to clarify that the EMF of the battery is 115 volts. It is an ideal battery, so there is no internal resistance. The question also states that the 45-watt lamp passes a current of 0.39 amps, while the 100-watt lamp passes a current of 0.87 amps. Draw a diagram of the circuit and then calculate the resistance of the 45-watt lamp and the resistance of the 100-watt lamp. There are many ways to draw this circuit, but since the two lamps are in parallel with each other and with the battery, I chose to draw it like this. I'm going to use resistor symbols for the two lamps since we are only trying to find the electrical resistance. So let's say this lamp is the 45-watt lamp. I'm going to call it R1. The other lamp is the 100-watt lamp. I'm going to label it R2. And I'll label the battery as 115 volts. The question tells us that we have a current of 0.39 amps going through the 45-watt lamp, so I'm going to call it I1, where I1 is equal to 0.39 amps. We will then have a current I2 of 0.87 amps going through the 100-watt lamp. There are a few different ways to find the resistance of the lamps, but here's the one I used. We know that one of the ways to calculate electrical power is to use the formula power equals I squared times R. So for the 45-watt speaker, we know that 45 watts equals I1 squared times R1. I can rearrange that so that R1 is then equal to power divided by I1 squared. With numbers, that means we have 45 watts divided by 0.39 amps squared. This gives us a value for R1 of 295.858 and so on ohms. I'm just going to round that off to 3 digits, and so R1 is going to be 296 ohms. We can use the exact same technique for R2, where we will have the power of the 100-watt lamp divided by I2 squared, which is 100 watts divided by 0.87 amps squared, which gives us a resistance, R2, of 132.118 ohms, or I'm going to round it off to 132 ohms. So we now have the two resistances, so we have successfully finished the question. As always, feel free to get into contact with me if you have any questions or concerns about this example. I'd like to thank you all for watching, and I hope you have a great day.